new Cartesian sign convention. New Cartesian. Suppose for concave mirror, this is principal axis, this is pole. We have to measure the distance of image of object, focal length, radius of curvature. All the distance are measured from the pole. This is the ray direction. So the ray direction is in this way. For measuring the distance, pole is treated as origin. That is, all the distance are measured from origin. Measured from poles. The direction, if you are measuring, this is the focal point, this is the center of curvature. The distance we measure from pole to this is focal distance. We are coming against the ray direction, against ray direction, the distance are negative. Therefore, f is equal to negative. F is equal to negative because we are measuring from here to here, from pole to, so we are coming against the ray direction. So this distance is negative distance. This is R. We are measuring from R from here to here. It means we are coming in this direction against the ray direction. R is also negative. Therefore, focal length is negative and radius of curvature is also negative. Suppose if the object is here, U is equal to the distance of object from pole. So we are measuring from here to here. This way. So this is U. U is equal to distance of object from pole. So U is also negative because we are coming against the pole direction, against the ray direction. And image, suppose if the image is somewhere here, in this case V is the distance of image from the pole. This is also negative. And if the image is here, so we measure the distance from here to here. This is V. In this case, V is equal to positive. This is the case of concave mirror. In case of convex mirror, this is the bulged portion. This is refracting surface, this is principal axis, this is principal axis. So object is here. If the object is here, this is the focal point, this is the center of curvature. This is the ray direction. This is ray direction. So this is subject. If image is formed here, this is focal length, this is pole, this is center of curvature, radius of curvature. this is center of curvature, this is a radius of curvature, this is the object distance, image distance from the pole, and this is from the pole object distance. Since object is, we are measuring from the pole against the ray direction, so u is equal to object distance, which is measured from pole against the ray direction. It will be negative v. Along the direction of v is from pole along the direction of ray, so it is positive, and focal length is positive along the direction of ray, and radius of curvature, it is positive. Okay. So the distance is measured from the pole. If you go along the ray direction, it is positive. If you go against the ray direction, it is negative. Simple. Now, the height of image. So this is concave mirror, principal axis. From principal axis, if the height is, this is A, B object. If the height is measured from the principal axis above the principal axis, that height is positive. If you are measuring distance, this is A dash, B dash, which is the image. If we measure the distance from the principal axis perpendicular downwards, that height is negative. If you are from principal axis above, vertically above from the principal axis, that height is positive. So this is h of, this is object, h of object in this case is equal to positive, h of image in this is equal to negative. So it's very simple. This will be treated as positive height, positive. This will be taken as negative. So this is case of concave mirror. Convex convex also same. This is convex. So this height is positive. This height is negative. In general, for measuring the distance measured from pole against the ray direction, if you are coming, it is negative, the distance is negative. From pole, if you are coming along the direction of ray, that distance is positive. Same way, height, if you are measuring from the principal axis, from this is principal axis, this is principal axis, above the principal axis vertically upward is positive, from the principal axis vertically downward, that is negative. This is the new Cartesian sign convention. Relation between focal length and radius of curvature. Let's take a concave mirror. For a concave mirror, should be a thin mirror. Thin mirror means the aperture. Aperture is very small. Small means the curved portion is almost flat. For thin mirror, for small aperture, thin mirror will have very small aperture. So therefore, here this is the principal axis. A ray is parallel coming and striking incident on the concave mirror. Ray coming parallel and incident on the mirror. It will pass through the focus. Any ray coming and parallel to the principal axis, it will pass through the focal length f. Now let us see after this one. This is the center of curvature. This is point C. This is pole, focal. So with respect to this, from C we draw a normal because the normal at this point of incidence, see at this point of incidence say B, at this point of incidence B, the normal is drawn from the center of curvature to the point of incidence, and the angle between the incident ray and the normal is angle of incidence, that is we call it as A. So we can say angle ABC is equal to angle of incidence, angle ABC, and with respect to the law of reflection, with the normal and the reflected ray, this is the angle of reflection. And I can say angle CBF is equal to R. This is I is angle of incidence, R is angle of reflection. Now this angle, let us take this angle. This angle is making an angle theta. So since by law of reflection, angle ABC is equal to angle CBF, that is I is equal to R, and angle CBF, angle FCB we call it as theta, and theta is equal to I because alternate angles. Therefore we can say since I is equal to R is equal to theta, so angle of incidence is equal to angle of reflection and angle of this theta. All the three angles are equal. Now this we call, what is this angle? See in this triangle, if they take this triangle, if we take this triangle, this is not theta, this will be, we call it this angle say we can X, this is theta, this is R, this is CBF. Thus we must have studied in the geometry, the external angle of a triangle is equal to sum of internal angles, that is angle PFB is equal to angle FCB plus angle FCB plus angle CBF. So that is, this is equal to angle FCB is equal to theta and CBF, angle FCB plus angle CBF is equal to angle of reflection, and that is equal to theta plus theta. Since R is equal to theta, so we can call it 2 theta. Therefore angle PFB is equal to 2 theta. So this angle PFB is equal to 2 theta. For a small angle, okay, for a small angle, for a small angle, but since the aperture is very small, therefore we are drawing a perpendicular to this, we call this point as N. So for small, this point will be always referring in ray optics, that is for small angles, sin theta and tan theta is approximately equal to theta. Small angle means angle less than 10 degree, we call it as a small angle. So angle less than 10 degrees, that is we can say sine of 9 degrees is equal to 9 degree, tan of 9 degrees is equal to 9 degree, and cos of theta is equal to 1. This is applicable only for a small angles. So it means since the aperture is small, this is almost narrow portion. It is not curved portion, narrow portion, and N and P are almost at the same place. It means we cannot distinguish between N and P. In that case, we can call CP is equal to Cn, because P and N are almost located at the same point. Therefore, the CP is equal to Cn for small aperture, and FP is equal to F into N. It means this distance is equal to this distance is equal to this distance. Okay, now in this triangle, we'll take this triangle FBN. In this triangle FBN, this is the triangle FBN, FBN, as well as P is also here. This is 2 theta. Tan 2 theta is equal to opposite BN by Fn, or we can call it as BP divided by, or we can call it BN by FP, since FP is equal to Fn. This point and this point are very close together for small aperture, and we take a very thin glass whose aperture is always very small. So tan 2 theta is equal to this much, or tan 2 theta, since angle is small, this portion can be approximately equal to 2 theta is equal to Bn by Fp. And take this triangle CBN. Tan of theta is equal to this triangle. Is equal to Bn by Cn, or Bn by, since Cn is equal to Cp. Therefore, or we can approximate this for a small angle, tan theta is equal to theta, so we can say approximately equal to 2 theta. Therefore, 2 theta is equal to Bn by Fp. 2 into what is theta? Theta is equal to Bn by Cp, which is equal to Bn by Fp. Or we can say, you can cancel this one, or twice of Fp is equal to Cp. What is Cp? Cp is the distance. Cp is equal to radius of curvature. This is equal to Cp, which we call it as radius of curvature. So it's equal to R. 2 into Fp, what is Fp? Focal length, focal distance. This is Fp. F. You can write it F. So 2 into F, or F is equal to R by 2. This is the relation between focal length and the radius. That is, the focal length is equal to half of half of radius of curvature.